Hello everyone, in this video we will be discussing on the pin configuration of 8085 microprocessor in detail. We will be having a detailed description about what are the pins of 8085 and how these would be operated. That will be. So this will be helping the students to gain knowledge in your 8085 pin configuration. This is the pin configuration of 8085 and how these have been classified into different categories. It has been shown over here like address bus and data bus is one category. The interrupts and serial communication, IO ports, crystal inputs and timing and control signals. Along with this one, some of the power supply lines are also shown over here. Coming to the first one, these are the two pins, pin number 1 and pin number 2 are the pins used for giving the clock to your microprocessor. 8085 microprocessor clock is being provided through these two pins, pin number 1 and pin number 2. And next one, coming to the next one, the pin number 3 and 36. I'm not going in a sequence for this one because of pin number 3 is reset out and the same one related option is reset in. These are the two pins we reset in and reset out, which are used for resetting a microprocessor and the peripherals connected to the microprocessor using of these signal lines. Reset in will be resetting the microprocessor 8085 and reset out would be resetting the peripherals which are connected to your microprocessor 8085. So these are the two pins which are used for reset in and reset out. Next comes is the pin number 4 and 5 which are used for serial communication, serial input data and serial output data. This is for receiving the bits to the microprocessor one bit after one bit. One single bit will be received to the microprocessor 8085. Serial out data is nothing but which is sending the data to the transmitter or through the accumulator. From the accumulator, it will be sending the data and it would be passed out to the outside world. That is nothing but the serial outlet. Next comes is about the types of interrupts and the pins related to these interrupts. There are 5 types of interrupts in your 8085. TRAP, RST 5.75, RST 6.5, RST 5.5, INTR. And out of all these interrupts, the priority of the highest interrupt, highest priority is given to the interrupt number. First one, that is TRAP interrupt. It is given the highest priority and it is said to be a non-maskable interrupt. Non-maskable interrupt means interrupt which can't be altered or it can't be ignored. Compulsory it need to be taken into consideration. And this TRAP interrupt is both edge triggered and level triggered. That is the most important. Similarly, now that all these three, all the remaining 4 interrupts are maskable interrupts. Unmaskable interrupts, and these are either edge triggered or level triggered. Like RST 7.5 is positive edge triggered, positive edge uh, interrupt, and then is RST 6.5, RST 5.5 are level triggered and are maskable. And the priority sequence is like this way. Try would be having the highest priority. Next, RST 7.5, RST 6.5, RST 5.5, and the least priority or the lowest priority is given to INTR. All these 3 are maskable as well as they are level triggered. Now coming to the next one, when an interrupt is been accepted, that would be sending by an interrupt acknowledgement segment onto this line. Pin number 11 is used to send the acknowledgement signal where the interrupt is being called. Then comes is the address and data line. There are 16 address and data lines. 8 are multiplex lines which are used for address as well as data. Like 80 to 87, you can see pin number 12 to 19 are used for address as well as data lines. Next comes is the you will be having the next one lines are from AC A8 to A15, which is used for sending at the addresses. So you totally combined with the 16 lines are used for just for address and latch, address and data line. Next comes is the ALE, address latch enable. This is the pin which is used to hold the address onto the octal latches. Once you pass it on high onto this one, this signal will be passed down to the outer latches that would be storing the address of the memory. 16-bit address would be stored. Yes. And these two lines, along with the memory or IO line, that would be giving you the information about what are the status of the microprocessor, whether it is going for read operation, write operation, halt, or output fetch. That is given by the pins like S0 and S1. They are taken into consideration. The inputs as S0 and S1 is 00, 01, 10, and 11. Having halt, write, read, output fetch operations respectively. Next comes is the whether you are going for read or write operation or output fetch operation from a memory or from IO is being given by this pin. Whether if your pin of this one is equal to 1, it indicates you are going for IO operation is been performed. IO operation is been performed. And the same when it is 0, memory operation is been performed. Mean to say we are going to read or write when from a memory if it is 0. We are going to read or write from an IO when it is 1. This is about the memory or IO pin. And combining all these three, memory or IO, S0 and S1, it would be like this way. One is output fetch, that is if IO is 0, IO is 1, we are going to read it the data from the memory. Similarly, next one is so 0 indicates memory. So 0 output fetch from a memory read, memory write, then IO read, IO write, because 1 indicates IO, 0 indicates memory. So 0 output fetch, 0 memory read, 0 indicates memory, memory read, memory write, IO read, IO write. Interrupt acknowledgement and halts is nothing but when it is high impedance and both our inputs are 1. Next comes about the read and write. Two lines are there. The read and write are used for reading a data or writing a data into the memory or any peripheral which has been connected. Both these two inputs are active low. Active low in the sense when you apply 0 onto these lines, output is mean to say there is performs the read and write operation. Next, after read and write, you will be having a ready operation. A ready indicates that you are ready to take in the data over here. Where usually when you are connected to the slower devices, that won't be synchronized with the clock of your microprocessor. So to avoid that one, we'll be going for using of a signal just like ready. So this ready will synchronize the clock. So say it will add some wait states in such a way that you will be getting an output. And last but not the least, you would be having one more is VCC and VSS. Before to that one, two more pins are there. Hold and hold acknowledgement. Hold and hold acknowledgement are the two pins which is used for DMA operation. DMA stands for direct memory access. You will be accessing the memory by taking up the system buses. So it could be sending the request to the microprocessor using a hold signal. Hold is an request given by a peripheral to hold the system buses. And the microprocessor would be give if it is free enough to give the system buses, it would be sending out a signal called as hold acknowledgement onto the pin number 39. It would be sent to the peripheral. So the peripheral will take this one and it will go for DMA. Last the two pins which are there VSS and VCC. VSS is the ground pin which is the pin number 20 and VCC is the power supply pins as a microprocessor 8085. You know that it requires plus 5 volts of power supply and that is provided to the pin number 40 or the VCC pin. So overall here this is the pin configuration of 8085 microprocessor and by the end of this lecture if you want this video and refer to the textbook, obviously it will be helping you understand the total pin configuration, which is used for your real-time applications or connecting a microprocessor to any of the peripheral or any other device. Thank you for sparing your time and watching this video. Thank you, everyone.